Today we're going through our full AI local software setup guide. We're going to be using Proxmox 9. We're going to be deploying LXC. I'm going to set up GPU Passthrough with you. Full suite of setup instructions that you can follow along with also on digitalspaceport.com with screenshots and circled key pieces of information you might want to keep in mind as you go through this. So we're going to be using Rufus to create our boot disk today. So Rufus 4.9, and we're going to use our Proxmox 9 ISO. I've already got those two, so I'm going to go ahead and start by selecting the Proxmox 9 ISO and make sure that you don't have any data on the USB drive that you're installing it to. It will destroy all the data on there. We're going to be using NVMe drives, and we're going to be using two of them in a RAID 1. This is called a mirror also with ZFS, a very secure way to have a setup. And if one of these dies for your boot drive, you're not out of luck and you'll still be able to continue operating. I'm going to show you the BIOS settings. Now, this is an AMD EPYC 7702 processor in here. A lot of this that you're going to see is hidden in different spots in a retail motherboard, the settings, but they're actually called the same thing. So you probably need to hunt around a little bit, but you can find these settings for sure in your configuration. So make sure that you have your SVM mode set to enabled. Next, when you come to your secure boot and your security devices, if you do have a security device, you could enable it here. That does enable you some additional things inside Proxmox, but it also creates quite a bit of additional compatibility, potentially issues. So I would urge you to not do that if you can avoid it. So your NUMA nodes per socket. If you are unaware, this is a high bandwidth application that we're talking about here. And in a single socket system, setting this on an AMD system to NPS 1 will give you the optimal throughput and bandwidth that you're looking for. If you have a dual socket system, you probably need to check with a couple of different settings to see which one's going to provide you the best bandwidth. The only way to really do that is with Stream or through testing with LLMs. So I would recommend you do that if you have a multi-socket system. This is a single socket system, and the reason I recommend single socket systems typically is because they are easier to configure and get the maximum performance. It doesn't quite scale like you get 2x by having two processors. You get a little bit of a degradation between those two, so it's more like 1.5 in a dual socket system. The next thing that we're going to do here is come over to our boot, and you'll note that I have UEFI selected for this. This is actually important because we're going to be using ZFS as root, and some of the features that you have, UEFI, EFI is needed for those in Proxmox. So that's pretty much it. If you wanted to change your boot order, of course you could do that here. And while I will show you how to set this up for quad GPUs, you can use just a single GPU, dual GPUs, you can go 8 GPUs with the same steps that I'm going to show you here today. And I'm going to select the UEFI USB drive that we have our installer put on. Okay, there we go. And we'll choose the graphical installation. So Proxmox is headless software, which basically means it runs as a service over your local network. This is great because you can access it from any of your machines through the web interface. And we're going to go ahead and select from the drop-down here the ZFS RAID 1 option, and you can see that we've got our two disks selected here. You can go to your advanced and back that off a gigabyte or so. Next, we're going to go ahead and hit next. Select your local time zone. Create a password. This will be used through the web interface in combination with the username root, and this password will log you in. The email address that you enter should actually be a functional email because you will get notifications of system performance issues that are sent from the Proxmox system itself. For your management interfaces, talking really quick about this, you'll see that I have two 1 gigabit internet interfaces specified here. The one that's green is plugged in right now, so that's the one that we're going to choose. And then I have one called CDC Ether. That's a kind of pseudo virtual interface, so don't select those. Just make sure that it's the one that's green, that starts with something like an Eno 1, and if you see IGB, that's Intel Gigabit. Next, we're going to create a host name that you can make up, and for myself, I use let's see here, type in there, prox0.spaceportdigital.com, which reverse of digital spaceport, and then give yourself an IP address on your internal network. So if you're on 192.168.1.blah, then you want to specify a non-parked address. So if you have DHCP ranges, make sure that this is not set inside that DHCP range. Make sure this is set usually lower than that. 40 is lower than my DHCP range. For gateway and DNS server, this could vary, but it should be probably if you have a 192.168.1 ending in .1. Click on next and it's ready to install. This installs pretty quickly. After that, we'll remove the USB, reboot, and our system will be actually accessed from the first time from the web interface. Go ahead and click reboot, and it gave you the IP address. You're going to append to the IP address :8006, and that will be a self-assigned SSL certificate. Once you see this screen here, and basically this representation of the KVM is going to be what you see on a attached monitor. You can go ahead and close out of this and go to a browser. And for our usage here, we're going to come over to Prox0, click on Advanced and Proceed. Enter in the credential that you created earlier. It'll let you know you don't have a valid subscription. You can click on that. And come over, I'm going to give you a real quick rundown of the layout. So on the left-hand side, you'll see that we have a server view column. There's a data center, and this is an organizational concept in Proxmox. So you can have multiple different nodes, which Prox0 is a node living inside a data center. You can also have multiple data centers with Proxmox Data Center Manager. You can manage backups for all of this with Proxmox Backup Manager, and you can have things like gateways with Proxmox Email Gateway. It's a very, very full ecosystem. It's actually insanely cool and really, really high performance and good. So if we check out Prox0 here, this is this node in particular, you can go to your summary and it'll give you information about your CPU. You can see we've got 128 CPUs pictured here. Granted, that's 64 and 128 when you have symmetrical multi-threading turned on. Same thing as hyper-threading in an Intel CPU. The RAM usage is about 503 available gigabytes, and that is of 512 that we have installed in this system. You can see that we only have 284 usable gigabytes of space for storage here. We are in EFI mode, and we are on a one-socket system. Of course, the big reason to go with the latest fact that it moved from 6.1 to 6.14 for the kernel, which has a lot of additional support things. Debian is the base of the system, so Debian Trixie moved up to that also. So, of course, Proxmox is following along closely behind that. The next thing that we're going to do is come over to Proxmox helper scripts. You should definitely review the source of your scripts, which you can do by taking the URL and reviewing it. Some of them are more complicated. I personally review the open-webui every time I pull it down, which is probably once every couple of months. But you definitely should take time, look, make sure that there's no weird URLs or base64 encoding in there. So let's go ahead, grab this, and come over to our Proxmox installation. We're going to come to the shell of Prox0, this node here, and paste this in. This is going to run through some post-configuration things for us. We'll click yes, and it's going to tell us about a sources change. Click OK. The PVE Enterprise repositories, those are available through subscription. They are not leading edge, and they are actually very stable, so you probably don't want to run those if you're doing things like AI in particular. We're going to go ahead and disable that for both Ceph and the PVE. We are going to enable the PVE no subscription repository. We are not going to enable the PVE test. That one is something that you can break stuff. You can disable the subscription tab there, and next it's going to ask you if you want to disable high availability. I would recommend not doing that unless you are seriously only going to be on a single node forever and you know it. And I would also say in the instance that you might be resource constrained where you might consider this, just buy some more RAM. And next it'll present the option for you to update Proxmox VE directly inside here. However, I'm going to actually select no, and we'll click OK here, and no. We're going to do the update after we check the repositories manually. It does look like everything is correct here, and we're going to go to updates. We'll click refresh, and after it says OK in the reading packages list, we'll come over here and we'll notice that it's got quite a few new things. We'll click upgrade on that. It's going to run through all of this. And a quick word about upgrading. You should not be an upgrade monkey. Your existence does not depend upon upgrading everything as fast as possible. When you have a good, solid, stable working system, you should really wait until there is either a compelling security reason or a feature that you think could provide additional performance benefit to do an upgrade. Now with this complete, we're going to go ahead and close out of the shell, and with Prox 0 selected, click Reboot. And this will actually reboot the physical node. This is needed if you have a kernel update that, of course, those happen fairly frequently, not super frequently, but fairly frequently. And especially when it comes to some of the steps that we're going to apply next, you don't want to be updating your kernel all the time. It can lead to breaking changes for your Nvidia GPUs. Yes, Nvidia GPUs are the recommendation, and just quick high level why. You get image generation, you get video generation, and you get, of course, your text generation. You get all of the software access to all of the environments, and Nvidia is what everything is optimized for. We still have Intel making pretty good strides with some of their GPU advancements, so I do expect to see better text generation performance from them in the near term. As far as video generation, that one is still outstanding. AMD is going to take some time also as they're working on their drivers, but really, even after they get driver support, they've missed the boat by so much. Nvidia is, without a doubt, still hands down the best recommendation. Of course, there's the Mac Minis. Everybody likes to point those out, but you're not going to do your video generation on those at all, and your image generation is going to be pretty slow if you do image generation on those at all either. So keep that in mind before you run out and buy a Mac based upon somebody's comment in any of the videos out there. As well, there's a lot of tutorials out there that are not based on Proxmox. Disregard them. Those bare metal installations are going to definitely bite you in the butt. And the reason why is because you're going to be changing software frequently. As you change software, as you install, as you upgrade, you will run into breaking changes. Even just setting things up, you're going to run into changes that break. Proxmox provides a very easy way for you to back up that does not require bare metal, which means basically reinstalling if you blow up your system. So definitely use Proxmox for this, and it'll make backup and restore so quick. Snapshotting, if you know you're about to do something, is just so intuitive. So keep that in mind when you're making your decision about tutorials and what to follow. If it's not based on Proxmox, gonna have a bad time. It's just a matter of time. All right, now that we're booted back in here, we're going to grab another Proxmox script, and you can just search up here for open-webui. And we'll grab this and come over to our shell again for Prox 0, and this will install the open-webui. So again, like I said, I review this whenever I'm installing it, so I took some time earlier and reviewed this. Definitely make sure that you're reviewing this. Don't blindly trust anything that you find that's a script that you're piping to bash, ever. And we will not enable sending diagnostics, and we're gonna do the advanced configuration. And we're gonna leave that as an unprivileged, and this is setting up an LXC container that will be container 100. The host name is gonna be open-webui, and I'm gonna add a -Ollama, because we're going to use the bundled Ollama in this. This is just a fast way to get up and running. Like I mentioned, llama.c++ with a bunch of information on configuring it and setting it up and getting llama swap working is coming in the very near term, as well as VLLM, in my opinion, are going to provide better experiences for you because they don't take forever to release models. Ollama has really drifted very far away from having up-to-date or even close to up-to-date model releases. So we'll click OK on that. As far as the disk size that you want, it's easy to grow an LXC's disk size. It's almost impossible to shrink it down without causing issues inside your LXC. So I would urge you to go very small. 25 is good for installing the system and Ollama and pulling maybe a model down. So we'll pull a model down and I'll give you the full look of it. We'll pull down a smaller. And as far as the allocate CPU cores, here's a tip that you really want to make sure you pay attention to. Even if you're on a hyper-threaded system, you probably just want to give it the amount of cores minus a couple that you have physically on that system. So this is a 64 core, 128 thread. So I'm actually going to give it just 60 cores here. That's actually where you're going to get the best performance. If you did something like 120, even though it's a 128 thread system, the performance would be substantially lower. The cool thing about LXCs is they're going to intelligently use resources like RAM. So if I put in 512 gigabytes here, it's going to actually size that down to like 500 gigabytes, but it's only going to use what it needs to use, and it's not going to reserve the rest of that RAM for its usage. So it shares resources. This is why LXC containers are vastly superior to what you get from VMs. However, VMs, of course, offer some really nice security things. If you are looking for a Docker host, for instance, you might want to go with that. So we're going to do 512.0.0.0 there and click OK. VMBR0 is our bridge, select OK, and that's all very default. As far as whether you want the IPv4 to be DHCP or static, you definitely want static. And the reason why is because if you don't do that, you're going to have it every reboot, you looking and hunting down the new IP address. So 192.168.1. And I'm going to go with 70, and then /24 will be the subnet that we're putting it in. 192.168.1.1 for the gateway, and the IPv6, I don't have IPv6, so I'm going to just disable that. apt cache blank, MTU blank, DNS search blank, DNS server, you can leave this blank and it's just going to use what the host uses, and the MAC address, just leave that so it auto-generates. If you wanted to put it into VLAN, you can do that right there. I do that manually later. Next, you can add pre-authorized SSH keys. We don't have one. We are going to enable SSH root support. I am not going to enable fuse support, and we are going to enable verbose. Verbose mode will basically allow us to see all of what's happening as it updates, and it does take quite a bit of time to install this very, very heavy Python application. As it's installing, don't change to a different screen because it'll kind of wig at the display sometimes, so make sure you just leave it on the display that's going on here until it's done. There's also a point in time where it'll come, probably in a couple of minutes, where you're going to need to select whether you want to install Ollama or not. I'm going to install Ollama on this because that's just an easy way for us to have that kind of combo that I think a lot of people will start there. I would really highly recommend Llama C++ and learning that as soon as possible, though. It will give you much better rapid access to models out there, and VLLM, when we get to that, will give you the launch day kind of support that a lot of people are after. We're going to go ahead and click yes to install Ollama in the open-webui container. It's going to give you an address that you can go to, and this is your web interface. We'll go to that really quick, give it a second to load. Okay, we'll click Get Started. And now you're logged in. So it looks like everything is operational here. We're going to actually go ahead and shut this down. Next up, we're going to come over and paste in some commands. Like I mentioned, you're going to need to go to digitalspaceport.com at the link in the description below to grab these, most likely. It will take a while to install this also. We're in Prox 0 for this installation, so conceptually, let me explain this while this is running. You want to be in your root system, which is going to be the node, Prox 0 here for this installation, and you want to then install select components into your containers that are going to utilize the GPU. So there needs to be a mirror of the same versions between the node and internally in the LXC container because they share the kernel space. So we've just installed the base packages so that we'd be able to install the Nvidia drivers. And one additional package you need to make sure that you install is DKMS. And we're going to update our headers and then reboot. Next, we're going to go to the Nvidia driver archive for Unix. Of course, this includes Linux. We're going to grab the latest production branch version, which is 580. If you click on that, we can go to the page and hover over, right-click, and copy link address. Come back over to your Proxmox virtual environment and wget space and paste. This will download the file. The next thing that we're going to do is change the permissions on the file so that we can execute it with chmod +x and then nv and that asterisk there. And then we're going to install this with DKMS. So, with an asterisk there. This will install the 64-bit Nvidia proprietary drivers, which you need to select that, and it will give you some information about your Nouveau drivers, and it's going to say, hey, by the way, I can disable these and add the mod probes so that we can rebuild the interim file system. Would you like the NVIDIA installer to attempt to create these mod probes? Go ahead, click yes, click OK. Now, it's going to ask you if you want to continue the installation. At this point, do not. Go ahead and abort the installation and rebuild the interim file system. Then we're going to reboot, and then when we're back, we should be okay to proceed with the full installation at that point in both the base system and the LXC container. It'll say installation failed, but that's really just kind of telling you what you already knew. All right, and we're back. Now just press the up arrow to get back to your installer. We're going to complete the installation this time, and then we're going to verify that it is working. I'm going to go to Nvidia Proprietary again. This time it will complete. And click yes on register with DKMS. You do not need to back this up, so click no and click OK. Now you can go ahead and run NVTOP, and you should see the 4 GPUs that we have here presented. Now, you can see each of these is negotiated for at 16x. This is one of the reasons that servers with lots of PCIe lanes are advantageous for things like this. It can actually really help you out. As well, you also probably see the POW at 350 watts. Now, limiting the power doesn't really negatively impact at the top end. So if you take this 350 and knock it down to say 250, you're not going to see a huge performance difference, probably 5%, which is a significant wattage savings, and I would urge you to consider doing that on your system. So hit Control-C to exit out of that, type cron tab-E, and just hit enter. At the top of this, we're going to type at reboot NVIDIA-SMI PM1 ampersand NVIDIA-SMI PL 250. That'll set all of the persistence mode to true and the power limit to 250 watts for all of the graphics cards. Hit Control X and yes. Now when we reboot the system, it'll automatically fire off an email when it does this to you also. So you can get a heads up this way if you entered in the proper email address or a valid email address when you set up your system, so that it can notify you when you've rebooted your system, and it will also tell you that you have set your wattage to 250. When we come back, we're going to verify that by doing an NVTOP, and it should automatically be at 250. Okay, so now we are back. It has rebooted. Let's run NVTOP. This should reflect the 250 watt power limit also on it. And yeah, you can see the idles on these pretty darn decent. 9 watts, 7 watts, 12 watts. I did, if you haven't taken a chance, repaste these, clean them, repad them. Definitely saw some improvement with doing that as far as the idle temperatures that these are able to sustain. So if you haven't taken a chance, watch the Quad 3090 GPU rig that I did almost a year ago, where I built this thing from scratch. And don't think that this is only able to be run on a quad rig like this. You could run a single GPU with the same stuff I'm going to show you here. You could run a dual GPU. Of course, we've got quads we're going to demonstrate, 8, 14, however many you want. You can run it on a desktop system like one of the Z440s, check the history for a lot of information on that. Something like a 3620, or even something like a desktop, just a normal Dell 7050 with a, really kind of small GPU, totally able to run this also. So I'm gonna hit Control-C to exit out of that. Now the next thing that we're gonna do is, if we come over to our open-webui and go to the console here, and we run apt install NVTOP, because it's not going to be installed by default. If we run NVTOP here, you'll see that it'll say no GPU to monitor. So come back over to your Prox0 shell, do an ls, grab the file name here, and we're going to do pct push the ID numerical of the container we're pushing it into, which is 100. We're going to paste the file name as it exists in the directory we're in, and the place we're sending it is to the root directory inside the LXC container, and we're going to give it the same name. So it's pushing it from here into there. You can now type pct enter 100, And inside here, you will see that you've got your driver as well. You do need to chmod this +x nv, and we're going to run it with a slightly different command, nv star --, and we're going to run it with no kernel modules flag because this is inside an LXC container. So the kernel exists outside this container that we're essentially running it in. And we're going to select the Nvidia Proprietary, click OK, OK, OK. It'll get right on with the installation. You don't need to back anything up, and click OK. Now click Shut Down Now, and that will shut down your LXC container. For every LXC container that you want to pass through your GPUs to, you need to follow the exact steps I'm about to show you. So go to Resources, click Add, click Device Passthrough. dev/NVIDIA 0. So NVIDIA 0 is card 0. I've got 4, so that'll be 0, 1, 2, 3, counting them up. So I'll add the rest of those. Next, you need to add your NVIDIA control and UVM and UVM tools. And caps. And like I mentioned, all of this stuff is on digitalspaceport.com because you definitely are going to need to copy some of this, I have a feeling. Okay, so with these all added in, I'm going to also take this chance to edit the swap and take that down to 0. We should be able to start this up, and when it boots up, we should be able to see those GPUs pass through now. So now I'll run NVTOP, and you can see that we've got the GPUs pass through and the wattage preserved on those. That's really cool. So I'm going to hit F10 really quick here to exit out, and we're going to come over to the OpenWEBUI. Now from here, there are a couple of things that you want to keep in mind as you're messing around. There's a couple of settings locations. There's an admin panel, and that's where we're going to start. And I'm going to take you to admin panel and settings. This is kind of the master settings location. And if we come to models over here, you'll see that we have no models listed. If we come to connections, the Ollama API that is built in here, you can see that reflected through the local host address 0.0.0.0 and the port 11434. And so if you're interested in grabbing the GPT-OSS, which I reviewed recently, you could do that by just going to the Ollama website, come over here, grab this, and come over and paste it in. This will download the 20 billion parameter model. Check back in the channel history for all sorts of reviews on these specific models and also a lot of information about what this all means. If you have not taken a chance to watch the local AI frequently asked questions, you really need to do that because everybody has those kind of questions. And it's very helpful if you watch through that before you ask questions because most of your questions are answered in that video. It covers quite a broad breadth, especially talking about hardware and how hardware is going to be impacted and what you should expect to see on your hardware. Now you can see the disk size looks like it is going to be pretty hard pressed to actually accommodate that. Really quick, I'm going to come over here and resize the storage, and I'm going to add in 10 additional GB, and it'll automatically grow it. There's nothing you have to do. It's just transparently going to happen underneath the hood. As soon as we have this verified working, I'm also going to show you probably one of the most important things that can save you tons of time and exactly why this guide is the guide you should be following. If you're not using Proxmox, you are making a pretty big mistake. And especially when it comes to what's going to happen next when we're using Llama C++, Comfy UI, VLLM, and a lot of additional Python things, the ability to restore quickly is something that I find myself using all the time, and I'm 100% certain you're going to find yourself using it quite often also. And we're going to go ahead and come over to a terminal window. And we're going to SSH into the container with the credentials for that container. The container IP again is .70 that we're going into. It's going to ask us to add in the key and to provide the password. And you can see we're inside here now. A few commands you might be interested in. DFH can give you some information about how much space is left and the utilization. You can see there that I've got 78% usage and not a ton of additional space, so it's going to be cutting it close, but it should be able to get there and finish. Yeah, we're at 99%, so we're right upon it here. And it's going to verify the file, and after that's done, we'll be able to actually run it. Okay, successfully downloaded. So let's go ahead and run another df-h, and you can see that we have only about 7 GB left of space. Next, I'm going to run NVTOP on this, and you can watch and monitor the GPUs as we load them up. And as it's loading up the model, you'll see it kind of load one of the GPUs fully here. And this is a thinking model, and it really fits pretty well inside at Quant 4, a single GPU. So one 4090, one 3090 can run this. You see the GPU utilization here at about 14.8 GB of space. So if we click the thinking, we can see it coming along here, and it flies along pretty decently. This is, of course, just a 20 billion parameter. Now, of course, one of the things that I've mentioned many times, the performance of multi-GPUs in Ollama and others, there is a lot of caveats here, but in others, is going to be limited if you are spanning the model's different layers across them. So it comes down to how you're using the model, whether or not you're really going to get a throughput improvement by having multiple GPUs. So the statistics on this one looks like our response tokens were about 65, our prompt tokens about 94, and it gave us that response in roughly 3,689 total tokens. So pretty fast. I'm going to show you now how you can back things up, and this is what makes this system just so ideal. So if we come over here and go to snapshots, you can either take a backup or you can take a snapshot. So there's a little bit of a difference between the two, and a snapshot is really just going to be able to be restored really quick, and I'll show you that entire process right here. A backup and Proxmox backup system are something that I would utilize if I was transporting a backup between systems or taking it to offsite media for longer term storage. So I'm just going to call this snapshot, and I could write a description if I wanted to. You do not have to stop it to take a snapshot, and just like that, it's done. That fast, we've got ourselves a secure backup. So at this point, I'm going to show you something pretty cool. We're going to go and I'm going to delete the model that we just downloaded and manage models, select delete model from the dropdown and click delete. So we just deleted that model. When we refresh, it's gone. Now I'm going to come over to we can come over to snapshots, click on the snapshot that you want to restore and click roll back. Click roll back on it. Now we'll go ahead and start the container back up. And type Ollama list here again, and you can see the file's back. So make sure you utilize snapshots frequently. That is a very good way to save yourself from some real problems that you can run into. I think this is a pretty good introduction. Let me know what you think in the comments below. And a huge special thanks to our channel members. Thank you for signing up, and you can learn more about that down below at the link to join as a member. You guys really do make it possible, and also everybody that tosses me buy me a coffees and Patreon members. Really do appreciate it. Used it to buy a GPU recently, and probably going to use it to buy more GPUs in the near future. Now, be sure to check out these two videos here so that you can get up and running with llama.c++ next, and also VLLM. VLLM is going to give you that same day runtime support and amazing performance, kind of manual, and definitely has a lot of configuration that we need to do around that. And llama.c++ has just a ton of flags and things that we need to configure, so that's going to be a separate video also.